Okay, we're going to do section 2.3 on intermediate algebra, Martin Gay. And we're going to be doing the even numbers up to number 29. This says solve each equation for the specified variable. Okay, W, number 2, W equals G times H. Now, G times H, it's understood that those are multiplied because those are two variables next to each other. Okay, so we're going to solve for G. So what we're going to do is we're going to take the H, move it to the other side. W over H equals G. Or G equals W over H. It's conventional to put the one that you solve on the left-hand side, but not absolutely necessary. Okay, that's number 2. Number 4, volume equals length times width times height. Okay, solve it for W. Move the L over, move the H over. W equals volume divided by L times H. And L of course looks a lot like a 1, so you can make it look a little bit more like an L, I don't know. And when you're on a typewriter, it's okay. On a computer, it's okay. Okay, number 6. Let's try this one. A squared plus B squared equals C squared. That looks a little bit familiar. That would be the Pythagorean theorem if it was a triangle. But we're going to solve it for B squared. So we're just going to move the A squared to the other side. B squared is equal to C squared minus A squared. Okay? Now let's go to number 8. This one it says 2x plus 3y is equal to 17. Solve for y. So we're going to move the 2x to the other side, and then we're going to move 3 down into the denominator. We're going to have y is equal to 17 minus 2x, and then we're going to divide by 3. Okay? And you might argue that you want to somehow simplify this, but there's not really very much that could be done in simplifying it. You could write it as 17 thirds minus 2 thirds times x, but as far as I'm concerned, those are both perfectly acceptable answers. Okay, now let's go to number 10. P is equal to 2L. I guess I can make an L like that. Plus 2W. This would be, of course, the formula for a perimeter, because that's twice the length plus twice the width for a rectangle. But you don't need to know that in order to solve it. They want us to solve for W. So we're going to move the 2L to the other side. We're going to take a 2 and put it down to the bottom. And we're going to end up with W equals P minus 2L. Then we're going to divide by 2. Okay? There we go. That's number 10. Now let's look at number 12. A equals P times 1 plus R times T. Okay, they want you to solve for T. So we're going to move the P down to the other side. We're going to subtract off the 1. Then we're going to put the R down to the other side. That might be a lot to do all at once, but we can do it. Take the A, divide by the P, subtract the 1, divide by the R. That's going to equal the T. Okay, but that could be simplified somewhat. T equals 1 over R times A over P minus 1. That looks, it's the same. It just looks, it might look a little nicer. But that's fine. That's the solution. That's what T equals to. So if you haven't tried doing all this in one step like I'm doing, it's something that's worth trying because sometimes you have to go outside of your comfort zone in order to make progress. And push yourself a little bit. Okay? Minus 9 times x minus 5 times y equals 18. Solve for y. Move the 9x to the other side, move the negative 5 down to end up with y is equal to 18, now plus 9x, and divided by negative 5. Okay? So that would be conventional to put the negative in front. You could have negative 18/5 minus 9/5 times x. But it's the same. I say that's perfectly fine. Okay, now let's go to 16. 16 says s equals 2 pi r squared plus 2 pi r times h. Now I recognize this. This is the surface area of a cylinder, Quaker Oats. That's pi r squared is the circular area. There's one on the top and one on the bottom. 2 pi r is the circumference all the way around, and then h is the height. But of course, you don't need to know that to solve this problem. You're going to solve for h, so we're going to move 2 pi r squared to the other side. We're going to divide by 2 pi r, and put it in the bottom. We'll get h is equal to s minus 2 pi r squared divided by 2 pi r. Okay? And you could try simplifying this, but it won't really look simpler. This is about as simple as it's going to look. And they didn't say that they wanted you to simplify it anyway, or to try to put it in any sort of a particular form. That form is fine. 16, okay, let's go to 18. A equals pi r squared. And this is a very simple formula for the area of a circle. Pi r squared, cornbread, r squared, pi r round. But in this case, we're going to solve for pi. So we're just going to move the r squared to the bottom on the other side. A over r squared equals pi. Okay? Okay, let's do number 20. Okay, F equals 9/5 times C plus 32. This is the well-known formula for converting Fahrenheit from centigrade to Fahrenheit, one way or the other. This way you plug in centigrade, you get Fahrenheit. But now they want us to solve for C, so we're going to subtract the 32. Then we're going to multiply. Now here's a trick. We're going to multiply by 5/9. This is going to go to the other side. It's going to get flipped upside down to be 9 over 5. So the 9 is going to go at the bottom, the 5 is going to go at the top. But the idea is it's a multiplicative term, so it's going to flip. Okay? So we're going to end up with C is equal to F minus 32. And then it's going to be multiplied by 5/9. So I should have, I'm sorry, I meant to put the 5 over the 9 here. The 9 ends up on the bottom, the 5 ends up on top. So it's going to be 5/9. Okay? And you can do a little bit of a sanity check. So here's something else. There's a little bit of help. Not for this exercise, but in general. We all know that 32 degrees Fahrenheit is going to be equal to 0 degrees Celsius. So that's easy to do, to check. That's like the guess and check. You put in 32, you've got to get 0. So you do get 0. So you know you didn't make a bad mistake there if you check your answer. Okay, let's go to 22. This one is a little bit more complicated. Use the compound interest formula to compute the table To complete the table and find the balance, A, if $5,000 is invested at an annual rate of 6% for 15 years and compounded n times a year. So there's the table. N, they want you to have it for, if it gets compounded once a year, twice a year, 4 times a year, 12 times a year, or 365 times a year. That'd be daily compounding. And A is the principal. Now, they're going to say A is $5,000. Okay, find the balance A. Okay, the initial estimate is going to be $5,000. So you put in A at 5,000. It starts off at 5,000. So I'm not going to do all of this because I need the calculator, and I'm not set up to do the calculator, but I can start off to do some of the easy ones. Oh, it's for 15 years. Okay, if it gets compounded once a year, that means each year you're going to get 6%. So you start off, after a certain number of years, you're going to have 5,000. It's going to be multiplied by 1.06 times n. Oh, well, n's a bad choice. I'm sorry. It should be the number of years. 15. It's going to be 15 in this case. So it would be m. You could call it m. M is the number of years. But in this case, it's 15 years. So the amount that you'll have after 15 years at 6% is 1.06 raised to the 15th power. Every year you get 1.06 times the amount you had in the previous year. So this factor is of interest. 6%, probably in 15 years, I bet it will double. And I don't want to multiply this out 15 times. That goes beyond my capability. But I do have a calculator on my computer. So I can take 1.06 and I can put in x to the y. I can put in 15 and equal. And it comes out to 2. This factor alone comes out to 2.397. Okay, so you're going to more than double your money. More than double your money. And if I multiply that by 5,000, I'll get the actual number of dollars, which is what they're asking you for. But getting the numbers into this formula is the challenge here. Now, if it were to be divided compounded twice a year, then this formula is going to change. So, and this probably was in this chapter, but you take 1 plus 0.06, okay, raised to 15 after 15 years. That's if it's compounded yearly, which is the so-called n equals 1. But if it's compounded semi-annually, which is n equals 2, the formula would be 1.006 divided by 2. But now it gets compounded 15 times 2 times. It gets compounded. So it's like 3% every 6 months, and it gets compounded 30 times. So the idea here is you take 1.03, you raise it to the 30th power, and that's what the formula tells you. And you find out that if this was a factor of 2.4, if you compound it semi-annually, you're going to end up with more money. So I'm going to take 1.03 x to the y 30, and that comes out to 2.43. This one here, let me do that one again. I forget what I got for that. 1.06 y to the x 15. That, I'm sorry, 1.06 x to the y 15 equals 2. it would be about 2.40. So you see that it's more. The factor is more. You're going to multiply 5,000 by this factor. Now, let's do the next one. If it gets compounded, this would be compounded quarterly. 1 plus 0.06 divided by 4. Now it's going to get compounded not 30 times, but 60 times. That's going to be equal to 1.015 raised to the 60th. And that's going to be a slightly larger number than this. Okay, so let's try that. 1.015. 1.015 y to the x, 60. That's 2.44. 2.443. Because what happens is it's going to approach a certain limit. It doesn't increase indefinitely. That's what's important here. Now let me do it 12 times. I'll move over here so I don't run out of space. 1 plus 0.06. This would be compounded monthly. So when it's compounded monthly, you only get 0.5% each month. Your money grows by 0.5%. And it's going to be 120 times. It's going to get compounded 120 times in 15 years. No, not 100. It's going to be 12 times 15. It's going to be 180 times. It's 3 times more than quarterly, so it's 180. 12 times 15 is 180. Okay, so let's just say that to 1.015. 1.005 or 0.5%. That's increasing by 0.5%. You raise it to the 180th power. Let's see what you get. 1.005 y to the x 180 times. And that comes out to 2.454. 2.454. Okay, it's just getting a little bit bigger, but it doesn't continue to grow indefinitely. Now this 365, that would be compounded daily. That's 1.006 divided by 365. And then that's going to be multiplied by 15 years times 365. Okay? So I'm going to have to put that whole expression into my calculator because, see, 0.06 divided by 365 equals, it's 1.00016, and then it goes dot dot, and then it's going to be 15 times 365. So I'm going to plus 1, then I do the y to the x, and then I put in 15 times 35, but I'm not going to try to do that, so I'll use parentheses. 15 times 365, close parentheses, equal, and here's what I get, 2.459. And dot, dot, dot. These are not exact numbers, okay? And hopefully that's just practice plugging numbers into a formula, okay? But also that kind of shows you a little bit about how the compound interest works, interest formula. Okay, that was 22. That one took quite a while because they were asking for a lot of calculations on that. Let's go on to 24. 24, well, this is the more stuff about the compound interest formula. A principal of $25,000 is invested in an account paying an annual rate of 5%. Find the amount in the account after 2 years if it's semi-annually, quarterly, or monthly. So just using the exact same formula we did before, first we're going to do semi-annually. That's A. It's 1.5% divided by 2. And then it's 2 years times 2. That's twice a year. And this is just a matter of plugging it into the formula. That's 1.2. That's 2.5%. Each time it gets compounded. And it's going to get compounded 4 times for a total of about 10%. 1.1038. Dot, dot, dot. I won't put in the exact number. But basically, that's the factor. You're going to multiply that by 25,000, okay? I'm not going to multiply that by 25,000 here, but you can do that. You'll find that you've gained. Basically, you know that if you get 5% per year and it's there for 2 years, roughly you're going to get 10%. But because it gets compounded twice a year, you're actually getting a little bit more than 10%, not as much as 11%. So now we're going to do B. That's quarterly. That's going to be 4 times a year. So the formula says you take the 5% per year, but it's done 4 times a year, so you're only going to get 1/4 of that each time it gets compounded. But you're going to get a total number of compoundings, or 4 per year. So that's going to be 1.05 divided by 4. That's 1.25, 1.25%. Yeah. 125 y to the x. In this case, I'm going to raise it to the 8th power. That comes out to 1.1045, rounding it off, dot, dot, dot. Okay? Still, it's only a little bit more than 10%. Okay? And then the last one was monthly. That's 1 plus 0.05 annual interest rate, but it's done monthly, so you only get 1/12 of that every month. But then it gets compounded 24 times in 2 years. It's going to be slightly more. So here I'm going to take 0.05 divided by 12, add that to the 1. Okay, then I'm going to raise that to the power, and it's going to be 24. I'm going to raise it to the power of 24. And here's what I get. 1.1049, dot, dot, dot. Okay? So you almost got another 0.5%. Okay? It's a complicated calculation. Okay, now we're going to go to 26. It took the Selby family 5.5 hours round trip. 5.5. To drive from their house to their beach house 154 miles away. That's a round trip, and find their average speed. Number 1, understand the problem. Reread it as many times as necessary. 2, translate it. So what's happening here is they're starting here at their house. Then there's the beach house. They drive, they turn around, they come back. The total time was 5.5 hours, and the total distance was 154 miles. Now the equation is that they want you to use is this equation. Distance is equal to the rate times the time, or in this case, the distance is equal to the average rate times the time, because they're not necessarily going at a constant speed, but it's the average rate, and what they want us to solve for is the average speed. The average speed is the rate. So that rate is going to be equal to the distance divided by the time, and it's going to come out in miles per hour, which is what you'd expect. That's where the units come in handy. 154 miles over 5.5 hours. And you get miles per hour. I'll just do that on my calculator because they made it so it wasn't going to come out to a nice round number. 154 divided by 5.5 equals 28. Oh, that came out to a nice round number. 28 miles per hour. MPH. Miles per hour. Yep. So that's the answer, 28. Okay. We solved it. Now we interpret it. We interpreted it as that they went 28 miles an hour. That's not very fast, but they're going to a beach house. Okay. Now, we're going to do 28. 1 year's low temperature in Nome, Alaska was recorded as minus 15 degrees. Centigrade. Write minus 15 to centigrade as Fahrenheit. And we're going to use the formula that Fahrenheit is equal to 9/5 times the centigrade temperature plus 32. It's just a formula. So we're just going to plug it in. 9 times 5 times 15 negative plus 32. And this we're going to be able to work out because this 5 and that will cancel each other to produce a 3. So it's minus 27 plus 32, which is equal to 5 degrees Fahrenheit, which of course is a very cold temperature. If you've ever been out in 5 degrees Fahrenheit, you'll know that that's cold. Okay. Anyway, let's go to the next one, which is going to be our last one for today. 30. Problem 30. 1 foot square ceiling tiles are sold in packages of 50. How many packages must be bought for a rectangular ceiling that's 18 by 20 feet? No, 18 by 12 feet, I'm sorry. 18 feet by 12 feet. Well, what we're going to want to know is, what's the total square footage? That's going to be 18 times 12. Okay, I won't use my calculator. I'll just do that out. 8 times 2 is 16, carry the 1. That's 36, and 18. Yeah, I knew 18 times 2 is 36. I could have just written that down. Okay, 1, 1, 216. So basically what's going to happen here is you're going to need 5 packages because 4 packages is going to give you 200 tiles. Each tile is 1 square foot. So you're going to have to use 5 packages and then you're going to have some left over. You're going to have 34 tiles left over, but that's the way it is. Okay, so the answer is 5 by 5 packs. Okay, that's all for today. Thank you.